Hello guys, and then welcome to another video. Okay, so as stated earlier, we'll be trying to solve practice questions on Kirchhoff's current law and then Kirchhoff's voltage law. So in general, Kirchhoff's laws, okay, because we have the current and then voltage laws. Okay, now so from the above example, you could notice that we have a certain circuit with 32 volts, okay, and then a certain current I1 passing through a certain resistor 2 ohms, and then when it gets to a certain node, the current branches into what, I3, okay, and then we have another 20 volts coming in with current I1 with, and then passing through 4 ohm resistor. Okay, now so whenever you've been given a certain question and then you are not asked to, or you are not forced to use a specific formula, okay, maybe using Thevenin, using voltage drop, or using what, current division rule, superposition, or Norton's rule, I would advise you to use the Kirchhoff's rule. Okay, it's quite straightforward and then very, very accurate. Okay, so without further much ado, let's just dive right into this video. Okay, so in this video we'll be trying to solve this question and other questions. Okay, some are assignment questions and then some are practice test questions. Okay, so we'll be solving this question right away. Okay, so let's get right into this solution. Okay, so now as stated earlier, you have to find what, a loop, and then use your Kirchhoff voltage law. Okay, and then in the process you tend to employ the what, Kirchhoff current law. Okay, so now let's proceed. So we have what, let's choose a loop. Okay, so we have solution. Okay, let's say this is our solution. Okay, so solution, so let's choose a loop. So let's choose loop A C D B A. Okay, A C D B A. So we have what, loop, we have loop. Let me change the color, okay, so that it will match with the loop. So we have A C D B A. Okay, so yes, that's our loop. Okay, so this is how it's going to look like. Okay, so what, using KVL. Okay, from KVL, if you haven't watched our first video on Kirchhoff voltage and current law, kindly do, so that you get to understand what we are about to do over here. So we have KVL. Using KVL, okay, we have what, 32 volts, okay, is equal to what, 2 ohm resistor, okay, times the I1. Okay, so you have what, 2 I1, okay, and then plus, because this current coming from the 32 volts is moving in the same direction, just like what, the I1. Okay, so I3 will be what, positive. Okay, so we have I3, okay, multiplying what, 8 ohm. Okay, so we could just make it 8 I3 or I3 times 8 ohm, it doesn't matter. Okay, so now this is our first equation. Okay, let's choose another loop. Okay, so let's choose loop what, C E F D E. Okay, C E F D C. Okay, but you could even use this E C D F E, so that our solution will be a bit easier. So let's choose loop E. Okay, E C D F E. Okay, yes. Okay, so that will also give us what, applying the same Kirchhoff voltage law. Okay, so I have E C D F E. So we have what, a certain 20 volts. Okay, which is equal to what? The 4 ohm times what? The I1, because the current is moving in the same direction, so it's positive. Okay, so you have 4I2. okay, now the I2 is also moving in the same direction with the I1. okay, so I3 rather, so I3 is what? Positive, so you have plus 8 what? I3. so you have another equation, what? 2. Now, so from here we can employ the KCL. okay, that's the Kirchhoff current law. okay, so you have KCL. okay, and we know that for KCL, the current entering a node has to be equal to the current or leaving a node. So from here, this is our node. okay, this is our node, right? So you could notice that this current I1 is entering this node, current I2 is also entering this node, but current I3 is what? Leaving the node. okay, so our KCL will be I3, okay, being equal to what? I1 plus I2. okay, so this will be our equation 3, right? So from here we could do simple substitution. okay, so substituting, so putting what? Equation 3 into what? 1. so putting from by substitution, so by substitution we have what? From 3 and what? Put 3 into what? Into 1. okay, putting equation 3 into equation 1, we will get what? A certain 32, okay, being equal to what? 2I, okay, plus 8I3. so you have what? 8 multiplying the whole of I3. I3 is what? I1 plus I2. so you have what? I1 plus I2. okay, right? So from here we could just simplify this to get what? 32, okay, to be equal to 2I1, okay, plus 8I1, okay, and then plus 8I2, and this will further give us what? 32, okay, to be equal to what? 10I1, okay, 2I1, and then 8I1 give us what? 10I1, and then plus what? 8I2. so this one will be our what? Equation 4. okay, now let's further simplify our equation. So we have, so from equation 2 you could notice that we also have what? 8I3. so you can also substitute what? 3 into 2 again. okay, so we have, so putting or put equation 3, okay, into what? Into 2. okay, put equation 3 into 2, that one will also give us what? So let's change the color over here. So you have what? 20, okay, to be equal to what? 4 what? So this are what? Equation what? 2, okay, 4I2. so yes, from here 4I2, okay, 4I2, okay, plus 8 what? I1, okay, plus I2, okay. So from here we can further simplify this to give us 20, okay, equals what? 4I2, okay, plus 8I1 plus 8I2. So this will further simplify to give us what? 20, okay, 4I2, and then what? 8I2, okay. So we have what? 8I1 plus 12I2, okay. So that will also give us what? Equation 5. So now you can then simplify and solve equation what? 4 and 5. So solving equation 4 and 5, we have what? 32, okay. 32 should be equal to what? What? 10 what? I1, okay, plus 8, sorry, let's erase this very quick. Okay, so we have what? 8 what? I2. So this is our what? Equation 4. So when you solve this simultaneously, you can use your calculator to solve this, okay? When you solve this simultaneously, you will end up getting what? I1, okay, to be equal to 4 amps, okay, and then what? I2, okay, to be equal to what? Yes, minus 1 amp, okay. Now, so from getting I1 and I2, we could just find I3 from what? Our Kirchhoff's current law. That's equation what? 3, okay. That's I3 equal to what? I1 plus what? I2. So we have what? So from KCL we have what? I3 being equal to what? I1, okay, plus I what? 2. That's from here, okay, from this expression, okay. So we have I3 being equal to what? 4, okay, minus 1, okay. I2 is what? Minus 1, so minus 1. It will give us what? 3 amps. Okay, so now you know what? I1 to be 4 amps, I2 to be what? Minus 1 amp, and then I3 to be what? 3 amps. Okay. This is very, very simple and concise, okay? Very, very simple and concise. So I1 minus 1, I2, how about what? 4, and then I3 to be equal to what? 3 amps. Now let's move on to what? Our second example, okay? Let's move on to our second example. Okay, let's see. For our second example, so after understanding this one, the second example will be quite simple, okay? Very, very simple. So let's move on to our second example. Okay, seems this one looks familiar because it's an assignment question, okay? Now let's try to solve this one, okay? So now let's apply our KVL, that's Kirchhoff's voltage law, okay? So we have what? You have KVL, okay? So applying KVL on loop what? Let's choose a loop. So let's choose this loop, okay? A, B, G, H, A, okay? So but first, let's identify our what? Currents, okay? This is very, very important and very, very crucial when it comes to solving Kirchhoff's law questions, okay? Or Kirchhoff applied questions. So you could notice that this current will flow from this voltage source, okay, through here. So we have what? Let's say this is what? I1, okay? Now, and let's see, we have another current coming from here, okay? But let's focus on here first. So once the current gets to this node, okay, it will split, okay? So the current will pass through here, I2, okay, current pass through I2, and then it will split, okay, it will split to this portion, okay? So you have current splitting over here. So once the current splits over here, you could just use your Kirchhoff, current rule to find your what? The split in the current, because I1 is entering the node, okay, I2 is what? Leaving the node, and then we know that current leaving and entering the node has to be what? Equal. So I1 is entering, I2 is leaving, and then this one is also leaving. So we could just write this to be what? I1, okay, minus what? I2, okay, because I1 is entering and then I2 is what? Leaving. So I1 is entering positive and then I2 is leaving, that's negative I2, right? So let's move on. Okay, so we have what? Let's say we have another current entering, okay, from here, okay. So from here I2 enter this point and then it splits up, okay, and then we have another current entering this portion, okay, and then entering and moving towards 10 volts. So let's say we have the one moving towards 10 volts to what? I3, okay. You can also do it otherwise. You can say that maybe the current coming from 10 volts is what? I3, and then you use your arrow sign, okay. The arrow sign will maybe move in this direction, so this will be what? The current coming from here will be positive, okay. But here let's focus on the main current coming from 7 volts and then splitting towards 10 volts, okay. So that's why this is also moving in the opposite direction, okay. Now, so from here you could notice that this I2, okay, and this I3, just like here you could notice that I1 was entering this node and then I2 was leaving. So this current was what? I1 minus I2. So let's see, I2 is entering this node, I3 is leaving. So what will be the current over here? Yes, you might be right, it's I2, okay, minus I3, okay, because I1 is entering the node and then I3 is what? Leaving. Now, so after doing this, the next part is I would say the easiest part, okay. So let's move on and then find out KVL using the respective loop. So let's say let's take loop, okay. Let's take loop what? ABGHA, okay, ABGHA. So we have ABGHA, okay, that's our loop, okay. So from here you could notice that we have what? 7 volts, okay, 7 volts, okay. You can just bring the 7 volts, you can just bring the volt, or you can just maybe omit it, okay. So let's just focus on the numbers first, okay. So we have 7 volts to be equal to what? 2I1, okay, 2I1, okay, and then this is moving in the positive direction, okay. So we have 3, okay, so this positive what? 3, and then you open bracket what? I1 minus what? I2, okay. Note that in case you made this the exact opposite, that's maybe the current moving in this direction, you get the same answer, but the value for the current will be what? Positive instead of I3 being negative, okay. Now let's move on. So we have this. So when you simplify this further, okay, you get what? 2I1, okay, plus 3I1, okay, minus 3I2, okay. So this one will further simplify to what? 7 equals what? 2, and then 3 will give us what? 5I1, and then what? Minus 3I2. So let's say this is our first equation. Now let's choose another loop, okay. So let's choose loop, this loop, okay, the loop in the middle, okay. Let's focus on the loop in the middle. So we have what? Let's choose BCFGB, okay. So let's choose loop. Let's choose loop BC, okay, FGB, okay. Yes, BCFGB, okay. So from there we know that we don't have any what? Voltage source, so the voltage source will be what? 0, okay, and that will be equal to what? I2 and then what? 5, okay, moving in the same direction. So we have what? 5 I2, okay, and then we have what? 2I2 minus I3. Okay, this moving in the same direction. Okay, the current is moving in the same direction, so it's positive. Okay, right, so we have what? Plus 2, and then you have open brackets I 2 minus I3. Okay, let's move on. So now the current will then move through this point. Okay, then pass through this point. Okay, so from here, when it reaches this point, this current will be what? I2 again. Okay, sorry, current will be I2 again. The current will be I2 again. Let me clean this one up. Okay, right, so this current will be I2 again. So I2 and then I3. When the current reaches this point, okay, when it reaches this node, this current will be I2. Okay, this will be what? I3. Okay, right, this will be I3. Okay, but this will be I2. So when it also reaches this point, okay, don't bother much about what I'm doing right now, because I'm just trying to explain how the current will split up. Okay, so this, sorry, okay, this current also, tend towards I1. Okay, because I1 and I2 is coming through this point, so I2 also enter this point. Okay, so we will have what? I1 minus I2 plus I2. Okay, so the I2 will cancel out, and then we have I1 over here. Okay, because this is negative and then the current is moving in the right direction. I2 is moving in the right direction, so it's positive. Okay, that's why I minus I2 will cancel out, and then we have I1 back, and then I1 will flow back. But what we are focusing on is what? The currents which are coming in. So we have what? Look, B, C, F, G, B. Okay, so we found that for 5 ohm, done that for 2 ohm. Now let's concentrate on what? The 3 ohm. So from here, you know that the current is moving in this direction. Okay, this direction, and then when you get to the 3 ohm, you could notice that the current direction was opposite. Okay, so we are moving in this direction. Okay, so this one is opposite to that direction, so we have minus 3 ohm. Okay, we have minus 3, and then we have what? I1. Okay, minus I2. Right, so now let's simplify this further. So this will give us what? 0 to be equal to what? 5I2. Okay, plus 2I2. Okay, and then you have minus 2I3. Okay, and then you have minus 3I1, and then you have plus 3I2. Okay, so negative give us what? Positive. Now let's proceed. So we have what? 0 to be equal to what? Now let's add the I2s up. So we have I2 here, I2 here. Okay, we have another I2 here, giving us what? So we have this 7. That's around 10. Let's say maybe we missed something. 5. Have what? 2I2, 2I3, and then minus 3I1. Yes. Okay, so that's it. So we have what? 5. Okay, so we have 5I2, 2I1 from here. 5I2, 2I2 minus 2I3. Okay, and then we have 3I1 minus 3I2. Okay, now let's check over here. We have a certain 2I2. Okay, we didn't add that 2I2. Okay, so from this 2I2. Okay, from here have 2I2. Okay, let me recheck again. Yes, there was a resistor here. Okay, I didn't bring that resistor. Okay, so there's a certain resistor. That's why I was trying to introduce the current source. There's a certain resistor over here. That's what, 2 ohm. Okay, there's a certain 2 ohm resistor over here. Okay, yes, so it's been corrected. Okay, so we have what, this current. So yes, so that's fine. That's fine now. So that's this is the 2 ohm. Okay, this is now the 2 ohm over here. Okay, so from here our 2 ohm, this is our 2 ohm over here. So now, so let's add that 2 ohm over here. Okay, have I2. Okay, so now this by that, and then to this, and then that will give us what, that's 12. Okay, that's 12 I2. Okay, and then you have what, minus 2 I3. Okay, let me write the 3 well. Okay, and then we have what, minus what, 3 I1. Okay, so this is that, and then minus 3 I1 is this. Okay, now let's say this is our equation 2. So now let's employ the third loop. Okay, let's employ the third loop. So the third loop will be this loop. Okay, so let's employ the loop from what, let's start from E. Okay, we could start from anywhere, but let's start from maybe C. Okay, so let's take the loop from C, D, E, F, C. Okay, C, D, E, F, C. So we have what, we have loop, let's say loop C, D, E, F. Okay, F, C. Okay, let's check again, C, D, E, F, C. Okay, so we have what, from C, D, E, F, C we have 10 volts. Okay, so we have 10 volts being equal to what, 10 volts being equal to what, a certain, we have a certain what, 2I3. Okay, 2I3. Okay, notice this, we are taking the loop from the C direction, not from the voltage source. Okay, in case we were to take the loop from D, C, F, E, D, I3 would be what, negative. Okay, but we are taking the loop from C, D, E, F, C, so I3 what, positive. Okay, we are taking the current, we are taking the loop from the current direction, not from the voltage direction. Again, if you don't get this, kindly go back and watch the first video. It will try, you'll be enlightened more. Okay, we are taking the loop from the current direction. Okay, not the voltage source direction. Okay, that's why I3 is what, positive. But in case we were to take the loop from the voltage source direction, that's from D, C, F, E, D, I3 will be what, negative. Okay, but since we are taking it from the loop direction, I3 will be what, positive. So we have what, 2 I3. Okay, now let's go back. Okay, so now C, D, E, F, C. So most definitely it means that I2 and then I3 was affected. So the direction is opposite to what, our loop direction. Okay, our loop is moving in this direction. Okay, but this current is moving in the opposite. Okay, so 2 ohm resistor will be what, negative. Okay, so we have what, we have negative 2. Okay, I2 minus I3. Okay, so when you further simplify this, you get 10. Okay, equals what, 2I3. Okay, minus 2I2. Okay, plus what, 2I3. Okay, so from here we have what, 10 volts equal to what, 2 and 2 give us what, 4I3. Okay, and then we have minus what, 2I2. Okay, this is what our equation what, 3. Now, so you know our equation 1, equation 2, equation 3. You could just, simplify it further and then find our answer. So we have what? Equation 3 over here. Our equation 2 is what? 0 equals what? 12i2, okay, minus 2i3 minus 3i1. So this is our equation 2, okay, and then our equation 1 is what? 7, 5, 1, and then minus 3, 2, minus 3. So we have 7, 5, i1, okay, and then minus 3i2 minus 3i2. This is our equation 1, okay. So when we solve this simultaneously, okay, let me solve this simultaneously. We will end up with what? Final answer, okay. Let's solve this simultaneously. So when you solve all the three equations simultaneously, you will end up with I1, okay, I1 being what? 2 amps, okay. Have I2 being what? 1 amp, and then we have I3 being what? 3 amps, okay. So now let me show you how to solve this simultaneously, okay. Let's go back to my calculator. So since you'll be dealing with something like this, you just need your calculator, okay. You pick up your calculator and then you just start punching. Okay, let's go back to my calculator. Let's see whether I can find my calculator. Okay, so we have what? Let's see. We have this, okay. Let's pick up our calculator, okay. So we have our calculator right here, okay. Now, okay, let's put the calculator right here, okay. This is how you punch your three equations, okay. So first, let's clear everything up, okay. Shift 9, 3, and that, and then you click on what? Mode, okay. Once you click on mode and you choose what? 5, option 5, that's equation, okay. So click on 5 and then you choose simultaneous equation, okay. Let's see, this is just two equations, so let's choose the right equation, okay. Let's choose 2, okay. These are 3 equations, okay. These are 3 equations, right? Yes, these are perfect equation to pick. So now let's do that again. You click on mode, okay. You choose 5 equation, okay. This is 5, so you choose the equation, okay, and then you choose 2, okay. These are simultaneous equation but of 3 what? Variables, okay. The first one are of just 2 variables, but this what? X, Y, and Z, so 3 variables. So let's choose what? 2. So after that, you start punching your values, okay. So start from equation 1, okay. You could start from 3, it doesn't matter, but I would advise you to start from equation 1. So let's start from equation 1, okay. Now, so we have what? 5i, okay, 5i. So notice that I1 is your X, I2 is your what? Y, and then I3 is what? Is your what? Z, okay. Keep that in mind. So we have what? 5, okay. 5 equals what? Minus 3, okay. Minus 3, okay. And then we have what? We don't have I3, okay, in the first equation, so we'll just use 0, okay. But for equation 2 we have I3, okay. When you get there, just insert. So we don't have anything for any value for I3, so we just use 0, okay. And then the last portion is what? 7, okay. Punch on 7, and then you move on to the second equation. So in the second equation we have what? I1 to what? Minus 3, okay. So minus 3, okay. And then we have I2 to what? Positive 12, okay. And then we have what? I3, okay. For equation 2 we have I3, so we have what? Minus 2, okay. and then we have what? Voltage what? 0. So click on 0. Now let's move on to equation 3. Okay, so for equation 3 we don't have any I1, so same applies to equation 1 where we didn't have any I3, so we use what? 0. So equation 1, for equation 3 I1 will be what? 0. Okay, I2 will be what? -2 -2i, so -2, that's -2i2, so -2, and then I3 will be what? 4. Okay, 4, and that what? Voltage will be what? 10. Okay, 10. So in case you didn't know this, you might begin solving the simultaneous equation, doing your substitution and all that. You'll be wasting time. Okay, it's better to learn smart. Okay, so just input this in your calculator and then you'll get your answers. Okay, so from here you notice that I1, okay, that's our x. That's why from the beginning I told you that make sure you note that down. Okay, know that your I1 is what? X, I2 is y, and then I3 is what? Z. Okay, so I1, which is x, is 2. The same applies to this answer over here. Okay, and then let's move on. Now I2, that's our y, is what? 1 amps. Okay, and then let's move on. And then what? 3 is what? 3 amps. Okay, yes. So from here we can notice that we found our currents. Okay, so these are final answers. So in order to prove the first in order to prove for the first example we did, let's go back to that example and then punch it on the calculator to find our respective answer. Okay, yes, let's come back to this point. Okay, so this simultaneous equation with just 2 variables, so this is where you use this. So let's clear this one up. Okay, let me drag this to this point. Okay, so this is an equation with 2 variables. You might ask, in case you have only 2 variables, so this is how you do for 2 variables. So you click on mode, click on 5, that's the equation, and then you click on 1. Okay, click on 1. Right, so here you go. We have what? Note again, I1 is your x, I2 is your what? Y. So we have what? Let's look at our first equation. Okay, so let's take maybe equation 4 as our first equation. We have what? 10i. Okay, 10i1, so we have 10. Okay, I1, and then we have what? Positive 8. Okay, so I have 8 over here, and our C is what? 32. Okay, I have 32 over here. Okay, and then let's move on to the equation 5. What? 8. Okay, 8i1. Note I1 is your x. Okay, so we have what? 8. Okay, and then you have what? 12i2. Okay, 12i2. Okay, and then we have what? Our voltage about 20. Okay, right. So from here you know that I1 is what? 4 amps. Okay, and then I2 is what? -1. So after that you just insert your what? Use your KCL to find your what? I3. You can just mathematically do it this way, or you can also use the calculator to do that in case you are interested. In case you are not, just use your simple algebra to find your value. But in case you are not, you can just use the calculator. You know that I1 is your what? X. Okay, plus I2 is your y. Okay, so yes, this is how you verify for I3. So you click on alpha x, alpha comma or x, and then click on plus, and then you click on alpha y. Okay, and then you click on the calc. Okay, this one. So it will ask for your x value, and then your x value is what? I1, that's 4. You click on equal to, and then you click on what? It will also ask for your y value. Okay, y value is what? -1. Okay, you input that over there, and then once you click on that, it will give you the what? I3 value, that's what? 3 amps. Okay, so in case have any other questions, kindly leave them in the comment section below, and then I'll reply to them. Okay, kindly subscribe to the channel so that you don't miss out on any other uploaded videos or tricks or whatever. Kindly like, share, and then I will see you in the next video. Bye bye.